I'm here today. I'm joined by Dr. Tang. We're going to be talking all things data center. Dr. Tang, could you please introduce yourself and a little bit about Gerchamp and how your focus has evolved within the data center and critical power sector?
Nice to meet you. Gerchamp is a company focused on next generation battery technology. Our core product is nickel zinc battery. This chemistry has a few key advantages: intrinsic safety, high power compatibility, and strong environmental performance. If we compare with the two most common solutions in the industry, lead acid battery are mature and safe, but bulky and limited in lifespan. We also can use lithium battery. It has high energy density, but in data center applications, safety is always a key concern. So what we are doing with nickel zinc batteries is to offer a better balance between the two, keeping the intrinsic safety close to lead acid batteries while delivering high power performance and better sustainability. At this exception, we are showcasing two things: our lead zinc batteries in different formats and our UPS battery solutions for data center. In simple terms, we are providing a battery solution that better fits for the needs of AI area.
And so, as AI driven data centers scale, how are the requirements for UPS systems changing?
If we look at the industry trend, the challenge is very clear. In the past, a typical data center rack was around 5 kilowatts. With AI and large model training, this has increased to 100 kilowatts and even high. So power density has gone up by 10 of times, and this brings completely new requirement to UPS systems. The UPS power module has already caught up. Today, for example, a 3U module can deliver around 100 kilowatts, but the battery size has become the bottleneck. If we continue use lead-acid batteries, their power density has not improved anymore. So the only way is to add more batteries, which make the battery room very large. Of course, we can use lithium battery, although the energy density is higher, but lithium battery generates significant heat on the high rate discharge and require strict fire protection and deployment standards. This adds both cost and complexity. So the challenge is quite clear. We need a battery that can deliver high power with remaining fundamentally safe. Whoever solves this will capture the next opportunity.
And so, why do you think there are more operators reconsidering traditional lead acid battery solutions?
Actually, lead-acid batteries are still the mainstream solution today. They are mature and safe, but in the AI era, their limitations are becoming much more obvious, especially in power density. In data center UPS applications, backup times is usually often 5 to 10 minutes. This means the battery must release a large amount of energy in a very short time, typically at 6 to 12 series for battery. The problem is with lead acid battery, the capacity is there, but it cannot be delivered fast enough. For example, 100 amp hour lead acid batteries can deliver close to its full capacity at a low rate, like 0.1 C. But in but in but if the battery discharge at 5 C, with a few minutes, it may only deliver 20 or 30 amp hours. So in so in short so in short duration, high power scenario like UPS, the usable capacity drops significantly. That's where needs oversizing. For example, you may only need 5 battery banks based on nominal capacity, but to actual deliver, you often need 2 or 3 times more batteries. In other words, using quantity to compensate for power. This increased the cost, not just the battery cost, but also space, installation, and even space that could have been used for servers. At the same time, on the frequent high-rate operations need acid batteries degrade faster. That's why in data centers, they typically need a replacement every 3 or 5 times. On top of that, environmental concerns are becoming more important, especially in stricter ESG requirement. We know lead-acid batteries face the pollution pressure. So fundamentally, AI has not just increased power demand, it has changed the constraints. In a high power, short duration scenario, lead acid no longer the optimal solution. That's why more and more customers are seriously evaluating alternatives like lithium batteries or nickel zinc batteries.
And so off the back of that, how do you see nickel zinc batteries positioned within evolving data center UPS requirements?
We believe nickel zinc battery is a good fit for UPS applications. The reason is simple. The nickel zinc battery is safe and have high power. For the safety, nickel zinc uses aqueous electrolyte, just like lead acid. So from a chemistry point of view, it is inherently safe. It does rely on external protection system to stay safe. This is very important for data center. Secondly, the power performance. This directly affects the space and cost. Usually, the nickel zinc battery can operate at 6 to 10 series, while still keeping around 90% of its capacity. So, 5 to 10 backup minutes UPS application, the energy can totally be delivered. This is very different from lead acid battery, because in lead acid batteries, the capacity is there, but it cannot be released fast enough. So you have to add more batteries in short time or backup time. For example, for the same power requirement, you can use few batteries and smaller capacity. In simple time, if we use nickel zinc batteries, we can operate few batteries, few cabinets, and much smaller systems. For example, a 9-hour nickel zinc battery can deliver similar backup time to 200 ampere-hour lead acid batteries at the similar time. Of course, the voltage of battery is similar. For example, our nickel zinc battery is 13.2 volt, and the lead acid battery is 10 volt. Especially if the backup time is shorter. For example, the backup time is 5 minutes. The advantage is even more obvious. So this is really a shift from adding more batteries to using few batteries with better performance. Also, on the high rate operation, nickel zinc battery lasts longer. Typically, it can reach more than twice the cycle life of lead acid in the kind of UPS applications. So in terms of sustainability, nickel zinc battery also has advantages. It uses aqueous electrolyte, no toxic organic electrolyte, and no heavy metal pollution issue. So most materials can be recycled, making the whole life cycle more environmentally friendly. Overall, nickel zinc battery is not just better in one parameter. It fits well across safety, power, lifetime, and sustainability for UPS application.
The Gerchamp has referenced the importance of the 5-minute backup window. And why is that such a critical operational threshold?
I think there are two main reasons. First, a longer backup time is always safer, of course, but it also comes with a high cost. The longer the backup time, the more battery capacity you need, which means more batteries, more space, and a high overall system cost. So it's not something you can just keep increasing. Secondly, the power infrastructure in data center has improved a lot. For example, the diesel generators are faster and the system switching is much more reliable. So the need for non-backup time has actually gone down. In the past, many systems were designed for 20 or 30 minutes of backup. But based on real-world practice today, around 5 minutes is usually enough. That 5 minutes window is mainly used to allow the generator to start to complete the transition or safety shutdown. So overall, 5 minutes is a good balance. It meets the reliability requirements without adding unnecessary cost. So in other words, when we evaluate the UPS batteries, we focus on how well they perform within 5 minutes window.
And another thing I wanted to ask you about is we know that safety is a major concern in data center environments. How should operators be thinking about battery risk, particularly in relation to thermal runaway?
When we talk about the safety, we often use one term, intrinsic safety. What does that mean? It means safety is not achieved by external protection. It comes from the chemistry itself. Nickel-zinc battery use an aqueous electrolyte, which is not flammable. The electrode materials are also stable. So for the metal level, it avoids thermal runaway. This is very different from lithium battery because the lithium battery use organic electrolyte which are flammable. In extreme situations, they rely on BMS, structure design, and fire protection system to manage the risk. In other words, their safety is managed, but our safety is inherent. In data center, what the customers really care about is certainty, because when something goes wrong, it's not just a battery issue. It can affect the entire facility, business continuity, and even data security. So the ideal solution is not to control the risk, but to eliminate it at the source. So that's why intrinsic safety is so important in data center.
And from that, what's the biggest misconception operators still have about battery technology in data centers today?
I think the biggest misconception is not that the operators don't understand the technology. Is that many decisions are still based on old habits. Most data center operators already know that UPS is a high power, short duration application. They do pay attention to power performance. But when it comes to actual system design, a lot of people still follow the logic from the lead acid era. For example, adding extra capacity or oversizing the battery. That approach made sense of lead acid battery. But with the new battery technologies, it's not always the best solution anymore. Another misconception is about safety. Many people see safety as something you can manage at the system level with BMS, file protection, and multiple layers of control. But in data centers, what really matters is certainty instead of managing risk. The better approach is to reduce it at the source by using a battery that is inherently safe. So I would say it's not lack of understanding, but it's more about updating the design mindset as the technology evolves.
Looking ahead, what will define the next generation of battery systems supporting data center infrastructure?
As a battery guy, people in the battery industry, we always trying to build a perfect battery. Ideally, it should have high energy density, high power density, absolute safety, and very long lifetime, even close to zero degradation. But in reality, battery technology is always about a trade-off. Improving one parameter often means compromising another. So for us, perfect doesn't mean maximizing a single metric. It means finding the best balance for specific application. For next generation battery in data center, we believe a perfect battery should have four things: intrinsic safety, high power and fast response, optimal life cycle cost, and strong sustainability. For our company, we are not trying to build the most extreme battery in one dimension. we want to provide the most suitable solution for specific applications. Thank you.
Well, thank you so much, Dr. Tang, for your time and for going so in depth about UPS and batteries.